Hello, everybody. This is Mrs. Galazzi, and I am going to start doing a recording on our Chapter 9 notes. As we begin this new chapter, you notice it's about chemical calculations. Oh, yay, right? Some of you will be happy because, yes, it does have math in it, and some of you will not be so happy. But I hope through the video and through other resources like YouTube videos, in addition to my videos, and anything that any questions you have that I can answer. Hopefully you'll be able to understand it. This is my third time recording this video because the first two times it messed up. I had tried to embed some videos into the PowerPoint and you couldn't hear the volume. So you saw somebody talking with nothing, no sound. Another time, somehow it was not sharing my screen, but it was showing a picture of me just talking without any PowerPoint or anything. So I have done this already 2 times. This is my third time. I'm sure hoping it'll work. So again, sharing the frustration that some of you have shared with me about having to do all these resources and things online and how difficult it can be. But there are some good things. I can do this anytime. It's 7 o'clock at night and I'm able to do this video again because I didn't work all day at school. So I'm able to at least take the time and have these resources. So, okay, better attitude. I'm feeling positive. Let's make this work. Okay, so chapter 9. For this chapter, you're going to want to have a calculator. Any calculator that you use for school, for math is perfectly fine. You don't need anything else. Any of that would work. It's got to be a scientific calculator that you can make exponents and things like that in it. Chapter 9A, notes in digital resources. 9A, there's going to be a couple parts to the notes this chapter. 9A is the beginning. And so I have the first download for 9A notes. And then once we finish 9A, I'll do another download for you of 9B. And depending on all the notes that I'm having to write with this new edition of the textbook, we may have a 9C, I'm not sure. Or it might just end with 9B. And do you need your periodic table and digital resources? I have those all uploaded for you. Let me go ahead and show you. Remember, textbook, periodic table. I have this in digital resources for you. And then I have, this is your notes 9A in digital resources that you can get. Hopefully you can print it out and fill it out because there's a lot of problems here that you're able to work out as we do the notes. If you can't print it, you could type it in. But I would suggest all the problems here, anywhere there's a math problem, you need to do that on your own paper if you're unable to type it in. It'd be a little cumbersome to type it in with calculations and stuff. But these are your notes for 9A, the first part, and our periodic table. Okay, we're going to go ahead and go back to our PowerPoint. And let's go ahead and begin this. Okay, the mole, it's about a mole. We're not talking about a little critter who digs in the dirt with a cute little nose and they're blind. But this is a word used to describe measurements of atomic particles, okay? Like how we say, now I've got my cat on the desk trying to take over. He's going to step on my laptop now. Okay, no, you can't get in here. Okay, so the mole is a calculation that we're going to use. Think of if we had a dozen of anything, we would have 12, right? So if I said, I have 12 socks, I have a dozen. And if I tell you I have a pair of something, you would say, I have 2, right? 2 of something. And so a mole is like a dozen or a pair, and it is a measurement. So its amount, definition is amount of substance in amount of substance, how much particles are in something. And it says contained in 6.022 times 10 to the 23rd atomic particles. And so this is a huge number, 6.022 times 10 to the 23rd. So remember our, when we actually extended this out and we were putting in scientific notation, remember after the decimal point, this would go out 23 places to the right. So after these twos, you'd put 20 zeros all the way to the right. So huge number. And of course, when we're dealing with atoms and molecules, we have to have huge numbers because they're so small that we use a massive amount of them for just a small tangible amount that we can actually see and use. Avogadro's number is what it's called. The symbol is N, capital N, lowercase subscript A. Amadeo Avogadro, he was an Italian physicist. Every time I see this name, Amadeo, I think of that song, Amadeo, Amadeo, Amadeo. Okay, I can't sing. It's okay. It's not my daytime job. Thank goodness, right? And my nighttime job. So Amadeo came up with the Avogadro's number, this huge number. Thank you very much, sir. And we still use it today. And 1 mole of helium atoms equals 6.022 times 10 to the 23rd atoms. And individual atoms, this many. So remember we said we have a dozen, we would have 12. Well, if I have a mole, I have this number. Doesn't matter what I have. Could be helium, could be anything else. So if I have a mole of water molecules, I have the same amount of molecules, 6.022 times 10 to the 23rd. Now look at the difference. Atoms, individual atoms, or a covalent compound is called molecules, or we could have formula units, which is an ionic compound. So don't let these 3 different words confuse you. They all mean the same thing, atomic particles. Just like the video you saw last week of Maribel, and I actually have that this week embedded again in our lesson plan so that you can see it and review it. And maybe some of you didn't get a chance to watch it because you were overwhelmed with all the things you were doing with all the classes. I'm going to put them here again, just as good review. She does pretty good with her videos. And I had some of you reach out to me and say, hey, I kind of like her. She's kind of funny. So I'm trying to find good, interesting videos for you in addition to the lectures that I give you. Okay, so speaking of her, in your lesson plan for Monday, April 13th, I have a video 1. And so I want you to go ahead and go watch that. I'm going to go ahead and go on with this, but I want you to pause this video. And if you haven't watched it, go watch it, because I actually have that built into the time for today, okay? Every day I'm going to give you about 20-ish minutes of lecture, and that would include my lecturing, but also showing videos from YouTube and things like that. So this video, I want you to go ahead and pause now and go watch it in lesson plans, and then I will continue. Once you're done with that video 1, I want you to continue and come back to this video where we'll continue in the lecture. Okay, so hopefully you've watched that video, video 1. Now we're going to continue because it helps explain moles and atom conversions. Okay, so let's look at this problem. How many atoms are in 4.5 mole sample of helium? And it has, I have a little road map here. I like to call it my little road map with stoichiometry, big word for conversion problems. We have mass in grams. We've got mole in between. Notice the arrow goes back and forth. I can go between mass and mole and mass. And then once I get to mole, I can go to mole and atomic particles, Avogadro's number. Notice arrows are double. I can go in between these two. If I wanted to go from atoms, atomic particles, to mass, I can't go a direct way. So I'd have to first convert to mole, then convert to mass, or first convert to mole, then convert to atomic particles. And remember, atomic particles could mean individual atoms, molecules, or formula units. And you might see the word even particles. Okay, so using this roadmap, we're looking at how many atoms are in a 4.5 mole sample of helium. Okay, How many atoms? How many? So that's what we're trying to find. I know she talked about finding in the video. And this is what we are given. We are given 4.5 moles. So we're given moles and we're going to atoms. Okay, so it's just a one step, starting with moles, converting to atoms. So let me go ahead and get an annotation here. And we will do our given, which is 4.5. Oh, this hideous, hideous writing with a mouse. Okay, it is a 4.5 moles of helium. So I'm going to put my symbol for helium. Okay, this is my given. And so we start out with our given, and we're trying to find atoms. Okay, so you make another line. Oh, it's so terrible, isn't it? I'm so sorry. I can't draw a straight line with a mouse. Okay, so I'm starting with moles, given. And here's moles. I'm going to atoms. And so this is like stepping stones, okay? Everything goes on top where we're going to, okay? So I've got moles here. I'm going to atoms. So I'm going to put atoms of helium, okay? So I have moles, 4.5 moles. I want atoms in helium. And the number that goes with atoms is always Avogadro's number. Okay, so every time you have those words, atoms, molecules, formula units, you need this number. Okay, so I'm going to go ahead and write that in. Oh, joy. 6.022 times 10 to the 23rd. Oh, so crude. Okay, now these are the stepping stones from here to here. And I know she talked about in the video where you can match the units. You want to match the units, okay? And so if we have moles of helium here, I want moles of helium here. With these problems, we're trying to cancel out what we don't need so that we leave the units that we do need, okay? So moles of helium, moles of helium. We've got those matching, okay? Moles of helium, moles of helium. Now, what goes on the bottom? Well, it's the ratio. We just said how many moles equals Avogadro's number? And we said 1, right? For 1 of any mole, it would equal Avogadro's number. So 1 mole is just a ratio, okay? Always 1 mole to Avogadro's number. Okay, to finish this up, we cancel out. Let me go ahead and we're going to cancel out these units because they match and we can get rid of them. And now we're left with atoms, okay? And we're going to calculate this. All you would do is just multiply what's on top. If there were any other number but 1 on the bottom, we would then divide also. But since there is only a 1, we don't have to consider it, right? It's not going to change the result. So we have 4.5. So get your calculator out. 4.5 times 6.022 times 10 to the 23rd. Hopefully you know how to do the exponential factors on your calculator. And I come up with a large number of 2.7099. Oh, that's terrible. 99 times 10 to the 24th. Okay, huge number. Oh, that's terrible. I'm so sorry. Okay, so 2.7099 times 10 to the 24th. The only thing is this is not rounded. If we only start with 2 digits, we can only end with 2 digits. So all of this has to go bye-bye. And so we will do 2.7 times 10 to the 24th. And it should be atoms of helium. Okay, so this would be our answer right here, 2.7 times 10 to the 24 atoms of helium if we're converting from moles to atoms. Okay, very important you use your units. Use your units, use your units, okay? Let's go ahead and clear all this, and then we will go to the next screen. Okay, molar mass. Every element on the periodic table has an atomic mass, okay? We looked at the periodic table. Remember the number, the decimal point number underneath tells it its atomic weight. We have atomic mass unit, AMU, or they could just call it mass in grams, or they also call it grams per moles, called for molar mass, okay? 1 mole of any element on the periodic table is equal to its atomic mass in grams. So remember in the previous screens, we said 1 mole of anything equals Avogadro's number. Well, 1 mole of anything also equals its mass on the periodic table. So it doesn't matter if I ask you for 1 mole of helium or nitrogen or oxygen, they all will have the total that is on the periodic table, which is going to be for each element symbol, okay? So here we are, periodic table. If I wanted to show you, that just went all crazy. Okay, so we see carbon here, 12.01. 1 mole of carbon equals 12.01 grams. So if I had some carbon and I could measure out 12.01 grams on my balance scale, I would have 1 mole. Nitrogen gas, if I could measure out 1 mole of nitrogen gas, I would have 14.01 grams of nitrogen gas. Oxygen, 1 mole, 16.00 grams of oxygen. So you can actually measure out in real world where you see something, feel something, measure something tangibly, and know how many molecules are in there and how many atoms and grams are in there, okay? So 1 mole of anything equals its grams. 1 mole of anything equals Avogadro's number, 6.022 times 10 to the 23rd. So if I had 1 mole of hydrogen gas, I'd have 1.008 grams or 1.008 grams per mole, also called molar mass. Okay, write the molar mass or grams per mole for the following. So on your notes, okay, use your periodic chart. In your notes, it asks you for 1 mole of carbon equals, well, we've got the 12.01 grams per mole. 1 mole of iron, Fe, 55.85 grams per mole. 1 mole of barium, 137.3 grams per mole. And then 1 mole of uranium, 238.0 grams per mole. So just looking at your periodic chart, anytime it says anything about mass at all, you need your periodic chart and the mass numbers. Okay, here is our video number 2, and it is in lesson plans for 13 Monday. So go ahead and pause. Actually, I'm going to end this video right now because when you're done with this video, you're going to go and watch the second video, okay? And so I'm going to go ahead and end this video so it doesn't get too long. I'm trying not to overwhelm you every day and only just give you about 20-ish minutes or so, under 30, because I know you have 7 classes. And so I'm going to end this video, and I want you to go watch video 2 in lesson plans for today. And I hope you guys have a wonderful day, and I sure hope this video works and there's no issue with it. Otherwise, I'll be recording it for the 4th time. All right, take care.